Right, so we're going to perform a test now with the 100 amp hour lithium ion battery from Super B. The calculated capacity of this battery at nominal voltage is 1.3 kilowatt hours, and we're starting the test with our energy monitor recording 199.23 kilowatt hours. So I'm going to put the electric fan heater on now, and we're going to apply pretty significant load to the battery and monitor how long the battery lasts and the amount of energy that it's actually releasing to the load. Obviously, we're going to have some inefficiencies within the inverter charger, which we'll need to add into our calculations afterwards. So here goes. So out of shot at the moment, I can let you know that the overload light on the 3 kilowatt multi plus is blinking, saying that we're actually now running at above the continuous output capability of the multi plus. But that's the only warning light that's currently present. The low battery and the temperature lights are off. So and the unit will operate at above its continuous rating quite some period. Let's have a quick look at what what we're seeing in terms of information coming from the Victron unit. We've got a laptop connected with VE configure running, and it's giving us some live data from the Victron unit. You can see here a table on the left hand side of values. So it's telling us at the moment that we've got an output of 230 volts. We're delivering 11.5 amps to the fan heater, and that equates to 286 amps of discharge from the battery. And the battery is holding its voltage at 11.7 volts, and I think you should be able to see that that's a pretty stable voltage. It's not really declining very quickly at all at this point. Okay, so we've resumed filming. We're approaching 20 minutes of running the load at this particular point, and the battery voltage is sitting at 10.5 volts, just dropped to 10.4. So we're starting to see a degradation of the DC voltage, and so we're approaching what we're going to get out of the battery on this particular discharge. So we'll just wait and see until we get down to the 10 volts and the inverter will cut off, and then we'll be able to establish exactly how much energy we've been able to deliver to the load. And there we are. Right, we're going to do a repeat test using the same load, which is a nominal 3 kilowatt fan heater, probably about 2.6 kilowatts. But this time we're going to run it on a conventional lead acid battery, a gel type battery, sealed valve regulated lead acid battery. So it's got the same nominal capacity of 100 amp hours, but obviously lead acid batteries are, the capacity of lead acid batteries is affected by the discharge rate. So we're going to just see exactly how much energy we can take out of that battery when we discharge it very quickly. Right, so I'm just going to turn the heater on, start the timer, and we'll see exactly how we get on. I'm going to turn on the load now, start the stopwatch, and I'll keep you informed as to what's happening with the inverter and how that's performing. So here goes. Right, so we've immediately got both the overload light and the low battery light flashing on the inverter. The DC voltage has already dropped to 10.2 volts, and this battery was fully charged prior to the test. And we're now drawing 325 amps from the battery. We're obviously drawing more ampage because the voltage is lower. So to get the same amount of power, we need to draw more current. DC voltage now dropped to 9.7 volts, and we're starting to see a degradation in terms of the AC output voltage from the Victron unit. Started off at 230 volts, it's now sitting at 218 volts, and that's just down to the fact that it's got such a low input voltage, it's struggling to maintain its nominal output AC voltage, so that's decaying now in line with the the DC voltage, which in turn means that the fan heater is absorbing less power. The voltage has gone down, the resistance of the elements has stayed the same, so we're now delivering less power to the fan heater. Okay, we're down at 9.4 volts now on the battery, so we're rapidly approaching the point at which the unit is going to turn itself off to protect the battery. It's now showing 9.3 volts on the display and we're off, so just over 6 minutes. Okay, so we're now going to perform the final test, which is applying the same load of 2.6 kilowatts onto a 220 amp hour gel battery, lead acid technology, and just comparing this also against the performance of the 100 amp hour lithium ion. So I'm going to apply the load now and start the timer. See the load's gone on, 2.624 kilowatts. Voltage is standing at around about 10.8 volts. So we've got a 307 amp discharge out of the battery. Right, we're caught napping there. The unit has just disconnected on low battery at 13.5 minutes. So with a final kilowatt hour reading of 201.05. So we'll just work out how much energy we've got out of the battery with those values.